Hi friends, this is Ashutosh Mohanty and I will give you a short lecture on V by F method, which is used for speed control of a three-phase induction motor. It is speed control of three-phase induction motor using V by F method. Now in this lecture I will also give you some real practical data which is obtained from an experiment of this topic. So at first I will give you a very brief theory about what happens in this variable frequency method. So let us begin with a very basic formula of EMF, which is equal to 4.44 frequency into maximum flux into number of turns. This number of turns depends upon the motor you are using, and this number of turns are generally fixed. It is a mechanical design. So I can write this formula as, let me explain this formula for you first. This E is the induced EMF. This 4.44 is a constant which can be derived from the equation, and this is the frequency of the supply frequency. In India we have 50 Hz frequency, and this is the maximum flux. It depends upon the EMF and the frequency of the system, and this is the number of turns as I explained earlier. So I can write this formula as V equal to 4.44 phi Fm into N. Now this V is the applied voltage. So I can write it V by F equal to 4.44 into phi M into N. Generally for an induction motor this whole term is actually a constant. So we can write that V by F is equal to constant. Fine. Now let us concentrate our topic on some concepts like how will be the method. I mean, what is the practical significance of this thing. So let us first do this by drawing a graph. V, this is the frequency axis, this is the voltage axis. Okay, so this V by F is actually a slope, and when any slope is constant, which means that the tan theta is constant. So up till how this will be constant? So we have to first write this is the rated frequency, which is 50 Hz, and this is the rated voltage. Let's say for a three-phase system it can be 400 voltage. So we have to draw this according to our system parameters. Okay. See, this is for the voltage curve against a variable frequency. Now as you can see is that when the frequency is increased up till rated value, the voltage increases, but beyond the rated value the voltage is constant. Now this is the characteristic equation of a V by F control of three-phase induction motor. Now let us concentrate on another very basic concept, which is torque and omega. So we can say that output power is equal to torque into omega, right? Here P is equal to output power, and here P is the output power, and T is equal to, you can see it is a load torque or simply torque for basic fundamentals, and omega is the angle, or you can say that omega equal to 2 pi f. So it is actually the frequency. You can relate it easily from the graph. Now what I will do is that I will show you that how torque and power will change in this entire graph. Okay, now beginning I want to also give you the basic concept of this frequency. Now there will be many questions, like we students we also have many questions about this frequency. Now for an induction motor, this frequency is also called the synchronous wave frequency. Now we represent synchronous frequency or you can call it speed, equal to 120 into F divided by P. Now this synchronous speed is equal to 120 into F, that is the supply frequency, and into the number of poles. Okay, now this is how this synchronous speed comes, and this is where the frequency of the system really matters. This is the pole numbers. Let's not confuse it with the power I have written here. This is the number of poles. Okay, let me write it very neatly because this is a very important formula. Now let us come to the graph we have drawn here. Here I said that this is the axis for voltage, this is the axis of frequency. Now I will draw the power curve. So how will my power curve be? Let's see here. Here the voltage is increasing, the torque is constant. This is why this V by F is constant. It means that the torque in this region is constant. After the rated frequency, the torque will decrease. So this is the graph of torque. Simple. Now see here, the torque is constant. The frequency is increasing, means omega is increasing. Let me repeat it. In this figure the torque is constant, and in this portion the omega is increasing. So the first case, torque constant, omega increasing, means the power will increase. So let me now draw the power curve. So the power curve will be like this. It will increase. Now after this region, after the rated frequency, what will be the nature of the power curve? The graph tells us the torque decreases and frequency increases. The torque decreases and the frequency increases. So our power curve will be a constant straight line. This is the power. So friends, I have shown you that how easily you can plot the voltage, power and torque versus frequency in a V by F controlled speed of an 3-phase induction motor. Thank you.